morning children. Today we will be discussing chemical equilibrium part 2. In part 1 we discussed chemical equilibrium and the features of equilibrium. In this video let's discuss Le Chatelier's principle and the factors influencing chemical equilibrium. Let's consider a chemical reaction, a reversible reaction. Formation of ammonia. Nitrogen combines with the hydrogen to form ammonia 2NH3 plus heat. This is a reversible reaction. Suppose the system is at equilibrium, means that the rate of forward reaction and backward reaction are equal. In this system, let us add more nitrogen. What happens to the equilibrium? The equilibrium changes. The equilibrium breaks. When the amount of the reactants increases, the rate of forward reaction is increased. More ammonia is produced. When more ammonia is produced, the backward reaction is also accelerated. Finally, after some time, again a new equilibrium is formed. Similarly, when we change the temperature, pressure of the system which is at equilibrium, the equilibrium changes, the equilibrium breaks, but the system itself readjusts, again attains a new equilibrium. This was proposed by the scientist Le Chatelier and is known as Le Chatelier's principle. According to Le Chatelier's principle, whenever a change in concentration, temperature or pressure on a system which is at equilibrium, the equilibrium changes, but the system itself readjusts to cancel that effect and again attains a new equilibrium. That is, once the equilibrium is reached, the system will likes to continue that equilibrium. Children, you studied the factors that influence a chemical reaction. Which are the factors that influence a chemical reaction? Concentration, temperature, pressure, surface area, catalyst, etc. Let's see what is the influence of these factors on a reversible reaction at equilibrium. For that, let's consider the first factor, concentration. So let us see what happens when we change the concentration of a reversible reaction which is at equilibrium. For that I am considering the same reaction, that is formation of ammonia. Suppose this system is at equilibrium. I am adding more nitrogen into it. When the amount of nitrogen increases, the number of reactant molecules increased. When the number of reactant molecules increases, forward reaction is accelerated. Then what happens to equilibrium? Equilibrium changes. But according to Le Chatelier's principle, it tried to reduce that concentration by accelerating forward reaction. That is, when the amount of the reactants increases, forward reaction is accelerated. So let us see the following situations, how it is affecting the equilibrium. That is, what happened to the rate of reaction. That is, the first case, more nitrogen is added. What happens to the equilibrium? More ammonia is added. Then let us see what happens. Same way, ammonia is removed from the system. Removed from the system and more nitrogen, hydrogen is added. So let us see what happens in these situations. The system is at equilibrium. When more nitrogen is added, the reactants are increased. What happened? Forward reaction is accelerated. The second case, more ammonia is added. Ammonia is the product. So when we add more product, which reaction will accelerate? Backward reaction is increased. The rate of backward reaction is increased. That is, when more product is added, backward reaction is accelerated. The third case, ammonia is removed from the system. When the product is removed from the system, only the reactant molecules are there. So which reaction is accelerated? Forward reaction is accelerated. So in a reversible reaction which is at equilibrium, when the products remove, the forward reaction is accelerated. More hydrogen is added. Hydrogen is also the reactant. When the amount of the reactants increases, forward reaction is accelerated. So that is the effect of concentration. That is, when the concentration of the reactants increases, forward reaction is accelerated. When the concentration of the products increases, backward reaction is accelerated. Okay. Then let us see the next factor, that is temperature. Let us take the next factor, temperature. What is the effect of temperature on a reversible reaction which is at equilibrium? I am considering the same reaction, that is formation of ammonia. N2 plus 3H2 gives 2NH3 plus heat. In this reaction, heat is involved. So it is a thermochemical reaction. In a thermochemical reaction, two types are there, endothermic reaction and exothermic reaction. In an exothermic reaction, heat energy is liberated, and in an endothermic reaction, heat is absorbed. So let us see that is which is endothermic and exothermic in this reaction. Which is the forward reaction here? The forward reaction is N2 plus 3H2 gives 2NH3 plus heat. This is the forward reaction. In this reaction, heat is liberated, means that forward reaction is an exothermic reaction. So we are getting forward reaction is exothermic. Then let us try to write the backward reaction. Which is the backward reaction? 2NH3 plus heat gives N2 plus 3H2. This is the backward reaction. During backward reaction, that is ammonia absorbs heat energy and decomposed. So it is an endothermic reaction. Heat is absorbed. So backward reaction is endothermic. Endothermic reaction. In this reaction, suppose on increasing the temperature of this reaction, what happens? The equilibrium. Equilibrium changes, but the system tried to reduce that temperature by favoring endothermic reaction. That is, when we apply heat energy, the system absorbs that heat energy, that is endothermic reaction. That is, when the temperature increases, endothermic reaction is accelerated. Here endothermic is backward reaction. So on increasing temperature, here backward reaction is accelerated because backward reaction is endothermic. So to get more ammonia, the temperature has to be reduced. But when the temperature decreases considerably, the threshold energy of the reactant molecules decreases. So by decreasing temperature, both forward and backward reaction reduces. So to get more ammonia, we have to provide an optimum temperature of 450 degrees Celsius for the production of ammonia to get maximum ammonia. An optimum temperature is required, 450 degrees Celsius. That is, this is the most suitable temperature at which maximum ammonia is produced. So that is the effect of temperature. Let us consider one more equation to explain the effect of temperature. The reaction between nitrogen and oxygen. When nitrogen and oxygen combines together to form nitric oxide. Nitric oxide is formed. And here nitrogen and oxygen absorbs heat energy and form nitric oxide. And it is a reversible reaction. Suppose the system is at equilibrium and we are increasing the temperature of the system. On increasing the temperature of the system, the equilibrium changes. But according to Le-Chatelier principle, it tried to reduce that temperature. Okay. For that, let us first find out which one is exothermic and which is endothermic reaction. Here the heat is on the reactant side. If the heat is on the reactant side, the forward reaction, it is endothermic reaction. And the backward reaction is exothermic. And we know that on increasing temperature, endothermic reaction will accelerate. Here endothermic is forward reaction. So on increasing temperature, forward reaction is accelerated. We will get more product. because it is endothermic reaction. So that is the effect of temperature. That is, when the temperature is increased, it always favor endothermic reaction. Then let us consider next factor, that is pressure. What is the effect of pressure on this system? So the factor pressure, what is the effect of pressure? I am considering the reaction, that is formation of ammonia. Nitrogen combines with the hydrogen to form ammonia plus heat. So that is formation of ammonia. You know that pressure has effect on gaseous reaction. This is a gaseous reaction. Nitrogen, hydrogen and ammonia all are gases. When we apply pressure, when we increase pressure, the volume decreases and molecules come closer. Number of collisions increases, as a result the rate of reaction increases. Then let us see what is the effect of pressure on a reversible reaction. It is a reversible reaction. Suppose this system, it is at equilibrium. We are increasing the pressure of the system, applying more pressure. So definitely the equilibrium changes. According to Le Chatelet principle, the system tried to reduce that pressure by favoring forward reaction. Let us see how is it. So for that, let us find out the number of reactant molecules and product molecules. So let us take number of reactant molecules. How many molecules are the reactants? How many nitrogen molecules? One nitrogen, and hydrogen it is 3. So total number of reactant molecules are 4 mole. 4 mole reactants are there. And number of product molecules. Number of product molecules, that is ammonia is the product. How many molecules of ammonia? 2 molecules. So it is 2 mole. So reactant molecules are 4 mole and product molecules it is 2 mole. The number of reactant molecules are more than products. So while applying pressure, the volume decreases, all the molecules come closer. Where the number of molecules are more, there the collision is more. So on reactant side, number of collisions are more. So the reaction is accelerated forward. So while applying pressure, volume decreases, molecules come closer. Where the number of molecules are more, there the collision is more and the reaction is accelerated to the other side. So here on increasing pressure, forward reaction is accelerated. Then let us consider one more reaction, that is the decomposition of phosphorus pentachloride. PCl5 decomposes to form phosphorus trichloride and chlorine. Suppose the system it is at equilibrium, all are in gaseous state, all these are in gaseous state, then only pressure has effect. While increasing the pressure of the system, what happened? The equilibrium changes, but the system tried to reduce that pressure by favoring, which side it will favor? By favoring backward reaction. Let us take the number of molecules. How many number of reactant molecules are there? Reactant side it is only 1 mole. Product side how many molecules are there? PCl3 1 mole and here chlorine also 1. So total number of products it is 2 moles. Where the number of molecules are more, on product side number of molecules are more. So by applying pressure, the volume decreases and the collision increases on the product side. As a result, backward reaction is accelerated. So on increasing pressure on this system, backward reaction is accelerated. So to get more product, we have to reduce pressure in this case. And let us consider one more reaction to explain the effect of pressure, that is formation of hydrogen iodide. Hydrogen combines with the iodine to form hydrogen iodide. Let us see what is the effect of pressure on the system. Suppose the system it is at equilibrium. We are increasing the pressure of the system. To find the effect of pressure, we are finding the number of molecules. Reactant side, how many molecules are there? Hydrogen 1 and iodine also 1. So, total number 1 plus 1, 2 mole. Product side, how many molecules are there? 2 hydrogen iodides are formed. So, product is also 2 mole. So, here number of reactants and product molecules are equal. So, what is the effect of pressure? Pressure won't have any effect. There is no effect. That is, when we increase the pressure, equilibrium won't break because the number of reactant molecules and product molecules are equal. So, that is the effect of pressure. Then let us see the next factor, that is the effect of catalyst. What is the effect of catalyst on a reversible reaction which is at equilibrium? Children, you know what is a catalyst. A positive catalyst always accelerates a chemical reaction. In a reversible reaction, when we add a catalyst, it accelerates both forward and backward reactions at equal rate. Equally they are accelerated. So, when we add a catalyst in the system, let us take an example, that is N2 plus 3H2. 3H2 gives 2NH3. Suppose this system is at equilibrium. When we add a catalyst, spongy iron is the catalyst used in this reaction. When we add a catalyst in this reaction, that is, it accelerates both forward and backward reactions equally, so equilibrium won't change. There is no effect. But a catalyst helps to attain a chemical equilibrium as faster rate. So, that is the effect of catalyst. So, I hope you understood the factors that is influencing the rate of a chemical reaction, that is on reversible reaction which is at equilibrium. Then let us consider one more equation, that is what is the effect. Let us consider the formation of sulfur trioxide that is, when sulfur dioxide reacts the oxygen to form sulfur trioxide and heat is also liberated. So, this system is at equilibrium. Then let us see the following factors, how it is affecting forward reaction. So, the factors are the amount of or concentration of oxygen is increased. Sulfur trioxide is removed from the system. Increased temperature. Then increased pressure. In this situation, let us see what happened to the forward reaction. The system is at equilibrium. Concentration of oxygen is increased, means concentration of the reactant is increased. So, which reaction will accelerate? Forward reaction will accelerate in the first case. Sulfur trioxide is removed from the system. When the product is removed from the system, which reaction is accelerated? Forward reaction is increased. Increased temperature. To find the effect of temperature, first we are finding exothermic and endothermic reaction. Here forward reaction is exothermic because heat is liberated and backward reaction is endothermic. Increasing temperature always favor endothermic reaction. So, when we increase the temperature on the system, backward reaction is accelerated because backward reaction is endothermic. So, to get more product we have to reduce temperature. So, it will favor forward reaction by reducing temperature. And the last one, increase pressure. To find the effect of pressure, we have to find the number of molecules. How many reactant molecules are there? 2 SO2, 2 mole and 1 oxygen. So, 2 plus 1. So, total number of reactant molecules 3 mole. And how many product molecules are there? 2 mole sulfur trioxide product side. So, where the number of molecules are more, reactant side number of molecules are more. By increasing pressure, molecules volume decreases, molecules come closer. The number of collisions are more on the reactant side. So, which reaction will favor? Forward reaction is increased. Okay, so this is the effect of the temperature, pressure, concentration, etc. I hope you understood the factors influencing a chemical reaction which is at equilibrium. Thank you.